those answers that you just got, does that move you closer to taking this on in-house, or does this push you further away? Same, maybe? We'll see. He kind of scared me when he said T30 is obsolete. We have one that we've still been trying to get registered this whole time. And now we have some T40s, and now I see we already need to move up to the T50, so where's it ever going to end? And we have grant money to pay for this stuff, so y'all would be in a much tougher boat. All right, so Jeremy Sandifer, State Specialist, Ag Technology for Small Farms. Half of my job is outreach, so I'm available to you free of charge to help you navigate through both this drone stuff and then more geospatial sciences writ large. I'm trained in physical geography, which means I know how to do GIS and remote sensing. And I've had this job at KSU now for about 10 years, so that's pretty much the extent of my agricultural knowledge. I didn't grow up on a farm. I definitely cannot grow things and have them stay alive the whole time, but I can help you map out a beautiful thing that somebody else is managing. So this is just just an example to show you see geospatial around you all the time, whether you recognize it or not. There's so much data out there. There's so many government agencies collecting data. There's so many smart people out there that are just mapping stuff out. And most of this data is available to you. Every agency you can think of has an online geospatial portal where they're just giving you all this stuff. So basically, you're pulling together digital layers to recreate, a representation of the real world, a digital twin, if you will. So that's kind of the GIS on the left side. On the right side, that's just highlighting an adjacent science called remote sensing, and this is more or less taking pictures of things, no different than you whipping out your iPhone and snapping a couple shots, but some of the sensors that we have are more advanced than your iPhone, like LiDAR sensors, or they were talking about multispectral earlier, and I'm going to show you a couple of examples of what some of that looks like. Geospatial, just zoomed out, kind of current state of the art. This is environmental monitoring at its best. So this is kind of the entire story of climate change up here shown. Not taking a position on it, and really not even saying that it's even understood as a process. But in terms of exactly what's happening today, day by day, is super clear. So when they say the sea caps are melting, the temperatures in the ocean are getting warmer, and they're not making this stuff up. They're not guessing. I mean, we're literally watching the movie of the Earth, right? There's thousands of satellites up there doing it. These are all modeled products, but there's measurements being taken every day. So what causes it, how you might hope to intervene, that's, not any more clear with an image like this, but what's taken place, what has taken place over the short and medium term, there's the evidence, okay? And later we can talk about any of those individually if they interest you. But what we're here talking about today is the drones. So the drones are different. Satellite data are kind of set on these missions. Maybe it takes them weeks before they kind of revisit the same place on Earth. So if you're trying to monitor your agricultural field, satellite data can be pretty problematic because every time you go outside, it's cloudy. It's literally cloudy every single day. And you can search through some of these satellite data repositories, and you may expect 40 years of data, but 23 straight years it was just cloudy, and the data you need is never there. But the drones are different. We're normally flying under the weather, so that's generally not a concern. And you get the shot when you need it, and you get it in super, super high definition. This is my favorite drone. This is the one they keep mentioning, the multispectral. The big sensor on the bottom is basically what's on your iPhone, but then those little ones across the top, two of those are situated in the near infrared, which is, it's outside the range of that your eye is sensitive to, but including that wavelength as a measurement allows us to give pretty precise measurements of the total portion of light the plant is consuming for photosynthesis. Okay, so you see all these NDVI maps all the time, where the more green, well, we'll look at one in a second, where like in that little one right there, it's basically just a play off because you're measuring different wavelengths, and we know that plants prefer certain wavelengths and We won't go into all that, but basically you can measure how much photosynthesis is taking place on the surface. So if it's like a big homogeneous cornfield, it should be homogeneously healthy. So if you have any places that are like lower health than everywhere else, that's a concern. And on your farm, maybe it's a low area or a place that holds water or has thin soil. So as the manager of that place, you already know that the health isn't going to be as good right here. But if you use a map like that and you find a lower health than you expected, that's, boom, you found a problem. You need to go out there and address it right away. So these are just different images that they take. Again, the one on the top is exactly what your iPhone would take, and the one on the bottom is more of an infrared image. Every time you take a picture, it's actually snapping, 5 or 7 images, depending on how many wavelengths it is, and then the software basically will composite those together into the image that you know as a picture. But your iPhone basically is doing exactly the same thing. You take a picture, it's taking those one red, one green, one blue, those wavelengths are measured separately, and then it composites that image, right? So your picture is actually a composite of these original images. Not important. But in terms of how you're extracting vegetation health out of this little diagram is just highlighting the fact that different parts of the leaf are going to be receptive to different wavelengths. So the red and the blues, the plants consume that for photosynthesis, and then infrared is reflected off. So it's important still to measure all the wavelengths so you can determine basically the total light availability, right? And then however much isn't reflected to the sensor must have been consumed at the surface. I mean, plants are green because there's no red and blue light, not as much red and blue light being reflected back out. But as the green vegetation gets less healthy, you start mixing the red and the blue back into it, it turns brown, just like finger paint. So you know this is working, makes sense like at that kind of a level. So they got it worked out, and they got a fancy little index for measuring it. So what you can do, this is a satellite product from the European Space Agency. If everything works out, you get every 3 days a revisit time. So what you're able to do, if you want, is monitor every agricultural field in a big area like the county or a country or whatever. And so this is pretty much how they're keeping up. They know exactly every acre that's tilled, every acre that's planted, every acre that's harvested. So there's never a question about how much food and everything's being produced. And then further, every 2 years, they're basically by airplane mapping out the entire country at much higher resolution to support the crop insurance programs. So don't tell them any stories because it's going to be on the record. They know what's going on. All right, so what does this look like when you bring a drone out to a farm? This little area, if you recognize it, is the kind of the goat grounds that are right back here. Drone just flies back and forth, takes a bunch of pictures. All those pictures overlap on the front and back and the side by side. Software just stitches it all together. That's kind of the science of photogrammetry. Just want to go to that one first. So before it can put all those images together, it literally has to approximate the geometry of the ground to be able to then overlay all those pictures where they line up perfectly. Not just from the bird's view, but the sides and everything. So you could see, this is time 1, time 2 for part of the organic section. You can literally see like how bushy it got. So if this was a pasture, you could know how tall the grass has got. And then if you have an understanding of what the density is, you could say, here's how much stuff I have out there, right? You basically have a volume, you need to give it a density, and you can take a guess at how much you have out there. And then this is that NDVI index. So this is time 1, time 2. So you're looking at the progression of the plants, not just for the whole plot that can be aggregated, but you can actually check the condition of each individual. So this is really important on a bigger scale. Whenever you plant a whole bunch, after a couple of weeks, you do an analysis like this so you can see your emergence. So you could say what portion of all the seeds I dropped actually turned into young plants. And then we can make a decision about whether or not you need to reseed. And we do that a lot here at this farm every year. And this is an example. This is a soybean field that's actually right at the front entrance. I won't go over what you all's project is, but all these different little plots, different soil stuff. Some of them have biochar in them. Some of them have increased nitrogen implemented during the growing season. Hopefully, that in some way manifests as a quicker growing soybean crop or one that's more vigorously converting sunlight and gas into biomass. He was pretty happy about the results this past year. Okay. In addition, and this is a cool one when it comes to before and after on the spray stuff. Okay, so I want you to just look again. That field, that goat area, is exactly the same land represented here in this picture. Okay, so previously you could see it's all green grass. It's middle of the growing season, so it's all green, nice and healthy. We can do, and this is no multispectral stuff, this is regular RGB. We can convert the RGB values into something called HSV model. That's not important, but the outcome of the image here is important. All these little clusters you see of the same color, it says that what's on the surface has exactly the same spectral characteristics, meaning for all the wavelengths of light, it's absorbing and reflecting at the same rates. Okay? Now, what those rates are isn't so important. The fact that the communities can be identified by their signature, that's the basis for classification. So what before looked like all healthy green grass, now you see it's a mosaic of 50 different communities of grass. And I didn't know this when I found out, but any 1 square meter of that entire field that you go and measure, you lay a little 1 meter thing around, and if you count the population of grasses in there, there may be 100 different kinds of grasses in there. It's never just one type of grass. Even though people generally are speaking about it in terms like that, it's almost never the case. It's always these huge populations that live near each other. But here, the whole point we're out here doing this is land that supports browsing for the goats. So when Dr. Ken Andrews was here over 4 years, we were monitoring this because they were actively trying to change the types of grasses that are out there. So they did different rotation strategies, they did different chemical applications, they did different mowing strategies, and they introduced a lot of those, is it roundstone, the little bags of seed that you put out that have the favorable collections already. And that's actually what you see down here in the bottom are some of the places where these bags were dropped experimentally, and we've just been watching those expand out. Okay, so this takes a lot longer to do to kind of watch the grasslands evolve, right? So that's a long story, but you can do it. You could do it with your regular iPhone, right? So this is not multispectral. A lot of actually what I'm showing you could do with your phone, assuming you could get and take the appropriate pictures. How do I know what each color is? When you have a map, you simply go check it out. Go to the greens, see what they are. Whatever you identified it is, everywhere that shows that same color on the map, it's exactly the same constituency of grasses, okay? So you can spend a lot of work highly detailing a small section, but then you can expand that information out and be able to identify places where you didn't go and assess, okay? All right, now I'm gonna talk just a little bit about, how much time do we have? 5 minutes? All right. Earlier, the Julian Farm folks were up here, and they already shared that they had a pear problem, and mostly my involvement was just out there that day to watch and to learn what was going on. But normally, if I were involved earlier, I would have went out and mapped this place out, and I would have first tried to determine exactly the extent of the pears existing there, so that then they could have had some idea then, because when he actually did the application, he just sprayed the entire area that they wanted. All right, but what if you wanted to do something between that not quite spot spray, but not a blanket application, right? You want to, where you have heavy infestation, you want to give it a heavy application. Where you have light, do a lighter application. If that were the goal, I'm going to walk through the workflow to give you that, and I actually did it after the fact, so it was out of order, but I just wanted to have it as an example, just so you can see what it looks like. So they already showed some of these pictures. Took me forever to make this small enough to get it in a slide. So this is a single image of immediately, some of the examples they show, they had places that were like 100% pear. And then they had other places that were really almost no pear. This is something that's kind of right in the middle. Now, because I'm training a model, I didn't want to give it the whole right answer first. I wanted to give it where pear is represented, but so a lot of other stuff is represented too. Because we train it only on pear, the model can only recognize pear, it doesn't see anything else. Probably won't explain all the details here. But anyway, if you zoom in close enough, you clearly can see the pear tree, right? And it's got a couple different colors. And then you see, I don't know what all these other plants are, but I just know that they're not pear. So really all we're trying to do is just train a model to be able to take any image and see if there's pear tree in it or not. Using that kind of HSV trick that I just showed you when I was talking about the communities of grasses, this is what an image like that looks like. Again, you can do this kind of stuff with your cell phone images. You can turn it into all different kind of computer vision-like variables, all right? And basically, it's just these are just different ways of measuring what can be seen in the image, okay? You go through, all you have to do in your image is you have to tell it, you just identify some of the stuff that's in the image. This is pear, this is not pear A, this is not pear B, on and on and on. Long story short, the very last image is the computer vision model answer for where it thinks it sees pear. So that's basically it. The one thing I want to point out, on the pear leaves, like if you look at the top of the leaf, there's these two dark sides with this nice little strip in the middle. The model I developed is pixel based, so it's not extracting out the shape that's the pear tree and then summarizing what's inside. We've trained it specifically to find those dark green edges. So in the results, you'll see that it leaves that middle strip out, okay? And that's fine. It's still showing you the occurrence of pear in the image, but it now has because we really wanted to know how many pears are out there. That was the initial question that we have. But because of the way I approach this, and we're not getting that strip, that means now that I could have several contiguous dots that still represent the same tree. So the count's now been blown out. But whether or not there's pear in the scene, super easy, easier than expected. So that's basically it. So you could stare at this a little bit and try to figure out. I see a couple little mistakes. So it's definitely not finished, and I wouldn't try to sell this to anybody for sure just yet. But it's relatively straightforward. This is probably 30 minutes of playing around. We could try harder. And this is no AI. This is nothing extreme. This is simple thresholding. Okay, so you're just kind of clicking around, finding the numbers you like, and going with them. They'll change a little bit per scene, but after you've done a couple of scenes, then you could find a way to normalize between the scenes. So if you're doing this on a regular basis, the opportunity would be for you to be mapping out all the sites that you go through and end up with a catalog that eventually could be turned into computer vision models and fed then directly into these Pix4D apps, where you just send it the image and it'll say, according to her model, here's the pears. That's right around the corner, I'm sure. So that was taken from a high resolution image. And then after I flew the mission and constructed the orthomosaic, it degrades the quality somewhat. So this is the test run on the completed orthomosaic, and we basically got pretty much the same results. Now, we haven't sent anybody out in the field to go and do a proper accuracy assessment where they would go and visit every red dot and say, yes, it is pear tree or not pear tree. But anyway, so that's what I wanted to show. And we can do that for any particular circumstances, whether it's like bush honeysuckle or, well, I actually don't have that many examples. But we could talk about doing it if you had a certain example that you wanted to do something like that for. They already covered Part 107 regulations because you do need a license to fly the drones if there's any compensation involved at all. The one thing I'm not super clear about is part-time farmer count, is that a compensation-driven activity? I think it is. Okay, so even if you're at your farm flying around, if you're using big equipment and it's in pursuit of business activity, you need a license, 100%. Spray drone, much bigger license, Part 137. It's a bigger thing to get into. Every drone flies has to be registered. Okay, so just like your car, before it flies, you have to register it. But the consequence of this is that everybody's pretty well known. So whoever's flying, and you're flying through an app, there's a record that you flew, and because it's registered, the trail leads back to you. So be careful out there. Follow the rules. Before we go out to the demonstration of the spray drone, does anybody have any questions particularly about that GIS workflow stuff that's involved in adding intelligence to your maps? Please.
For one or so question, and then we'll...
Before you ask, how many GIS people are in here, already do GIS remote sensing? Right on.
So what is the applicability and I guess potential threshold for, let's say, your common suspects in terms of land management in NIS? So your invasives like honeysuckle species, multiflora rose, Bradford pear, obviously, privet, autumn olive, those type of species. Is that applicable, and what would that workflow look like to factor in those additional species into your model?
Good question. I haven't played with all those examples, but bush honeysuckle, for example, the workflow is exactly the same, but for different, depending on what you're looking at, normally when I look for Bradford pear, I always go when it's flowering. So I can fly the property, and then I'm really not even doing what I just did here. I'm just looking for white. Same with bush honeysuckle. If you fly a couple weeks before this time of the year, and then at the very beginning of the growing season, the only thing that's going to be down there in green is going to be bush honeysuckle. So in that regard, if you pay attention to when you're out there, you have a better shot at isolating if what you're looking for can be isolated. Trying to do a tree census in the middle of the summer, for example, nearly impossible. Everybody's green, everybody's vibrant. The greenness really then is a function of how much moisture has been out there. So it's super hard then. But some of those other examples, I don't know. We have to check them out. If anybody wants to experiment like that, I'm your guy. So that's my specialist position. I'm allowed to go and explore and learn, and I can work with you. I can bring our equipment. It's free of charge. I can't help you make any money, but if we're just exploring, I can work with you on that. Certainly if you're a producer, private landowner, producing stuff, I'd love to work with you.
Are you going out to the spray drone demonstration?
I think so, yeah.
Okay, so Jeremy's going to be out there with you guys if you're interested in checking out our spray drone demonstration. You have any other questions for him, he can answer them while you guys are heading out that way. So thank you so much, Jeremy.
All right, well, thank y'all for being here today.